Hi, I'm Paul Battaglia. Welcome to section 9.3, Hyperbolas and Rotations of Conics. I'm joined today by Carla and Dave. Thanks for being here.
Thank you.
Thank you.
As we begin this section, I want to point out something that you might want to try, which actually would take place before the actual lesson itself. With the advent of things online and videos that we can watch, think about asking your students the night before this lesson to watch a link maybe you would provide to the formation of a hyperbola, and maybe even some uses for it, or even some videos of satellites following hyperbolic paths, just to motivate discussion when they come back in the next day. Now, as for the lesson itself, Dave is going to talk a little bit about how he gets his students to understand how these hyperbolas are formed and how they move. Dave?
Yeah, so whenever I'm teaching about hyperbolas and ellipses, I like to stress that all they are extensions of circles, the circle equation that we were talking about earlier. And all we're really doing is taking that circle concept and maybe dividing the x or the y by a certain number, and now we're just squishing it a bit or stretching it this way. And then all a hyperbola is just putting a minus sign between them to now take that circle, squish circle, and making it go opposite ways. And then from there, they could play around with their graphing softwares to see what would happen if I alter this number, multiply or divide it by 3 or 4 or 5, right? What happens when we plug in 1, 2, 3 to see how all these graphs come about by just playing around, experimenting with their graphing softwares. And from there, they can discover where the asymptotes are for hyperbolas, right? Knowing where they are helps them graph and understand the concepts behind.
I think these, and this is going to be an opportunity for you as a teacher to look for students to show you that they know the difference between the equation. They'll know the difference graphically. What's the difference between the equation of a circle, equation of a parabola, equation of a hyperbola, eventually an ellipse, right? So these are the things that we want them to kind of take away as they now kind of form this broader, vast knowledge of conics. Now, our students are all different. They have different interests, right? Carla, at this point in the class, you might find some students interested in some very specific career paths, right? So why don't you tell us a little bit about what the teacher can look for and maybe encourage some students to look into?
I think this section is a game changer, because this is where my students can discover, maybe I want to be in space exploration, or I suddenly love physics in a way that I didn't know before. And they start doing work on their own, where they're now watching these videos that we told them to watch about things that they didn't even know they cared about.
And I think that's the thing. Sometimes as a teacher, you might be intimidated because you're not quite sure realistically. Maybe you don't have the background. I didn't study satellites. I didn't study elliptical orbits or anything like that. But you can't rob your students of the opportunity to explore this stuff, because this might be that one section that makes them say, I think astrophysics is something I want to look into, or what have you. So I hope these tips have been helpful for you. Good luck with section 9.3.